The 17th question, calculate the wavelength of the wave generated by a tuning fork of frequency 256 Hz. Velocity of the sound in air at ordinary conditions is 340. So what is the given data? You are given the speed of sound as well as the frequency, and you are asked to find out wavelength. The same old concept. So we know that velocity V is equals to F lambda, or lambda equals to V by F, where the value of velocity, V means velocity of sound in air. How much is that given? 340, and frequency was given as 256 Hz, meter per second and Hertz, both in SI system. So simplifying this, how much we may get, children? It is something around, I'll check it out. 170,128. This is again 85, and here it is 64. If you are clear, you can also simplify 85 upon 64. It goes something like 1 time. Okay, or else I'll make it more simpler for you. 42.5. 42.5 upon 32, it is something regarding 1 point something. Okay, so divide this, children, you may get it 1.33. It's not 2.33, no doubt, because 2.33 means something more than 64 it should be there. Okay, so the correct option must be 1 point. Well, the next question, 18th question, a tuning fork produces 256 waves in 2 seconds. So what is given, children, here? Number of waves were given and time was also given. What you're asked to find out? Frequency. Children, we know that frequency is defined as number of waves per second, number of vibrations per second, or number of cycles per second. So number of vibrations per second or per 2 seconds time period. Number of waves per second you have to calculate, but as it was given in 2 seconds, so convert this. So 256 upon 2. So this was found to be 128 Hz. So option number 3 must be true. Number of waves per time period. Number of cycles per second or time taken. Well, question, children, concept oriented. So let us look into that. So what is the given value? In 1 second, it was given that in 1 second it produces 100 Hz, because frequency, what is frequency? Number of vibrations per second. So the frequency itself is 100 Hz. The frequency is generally counted for 1 second. So how many times it vibrates in 1 minute? 1 minute it contains 60 seconds. 60 seconds. What is the value of frequency you're asked to find out? So let us calculate the same, children. So dividing these two, we have 1 by 60 must be equals to 100 by F. Or cross multiply, we have, bring this F here and 60 here. So then you have F is found to be 60 into 100. This is nothing but 6,000 Hz. So correct option is 6,000 Hz. So how many times it vibrates, children? It vibrates for about 6,000. Okay, 6,000 times is vibrated. On the earth, a sound wave traveling in air has wavelength 1.6 into 10 power minus 2 meters. So wavelength itself was given as 1.6 into 10 power minus 2. Lambda was given. Velocity of the sound is given as 320 meter per second. You're asked to find the frequency. What are the given conditions? Lambda, V and F. So what is the relation between lambda, V and F, my dear children? So the relation between lambda, V and F is V equals to F lambda, and you're asked to find out frequency. So F must be equals to, bringing the lambda other side, we have V by lambda. What is the value of V? 320 meter per second upon lambda is 1.6 into 10 power minus 2 meters. Okay. So simplifying this, we have 320 upon, let us remove this decimal for our easiness. So if I decimal is removed, this is increased by 1, then 10 power minus 3. So this 16 goes 2 times, so 20 times. So the correct option must be 20 into, let us bring this 10 power minus 3 other side, then it will become 10 power plus 3. This will be equals to 20 times 000 Hz. So the correct answer is 20,000 Hz, and the second option must be true. Got it, children? The frequency of a wave traveling, frequency time. Okay. So no need of speed, whatever be the speed, we know the relation between the time period and frequency. Frequency is the reciprocal of time period. So frequency is the reciprocal of time period, or time period is the reciprocal of frequency. Okay, just interchange the terms. So T must be equals to 1 by, what is the value of F? F is found to be 25. So how much is the value of 1 by 25, children? This can be written as 100 upon 25 into 10 power minus 2. I simply divided and multiplied. I'll write it something. 100 upon 100 into 1 by 25. Makes no sense. Okay. So 1 by 25, 100 upon 100 is again 1. Okay. So this 25 goes 4 times. 4 upon 100 is how much, children? So this is equals to 4 upon 100. And it's found to be 0.04 seconds. Hence, fourth option must be true. I hope this is clear, children. 1 by 25 keeping like this. I simply multiplied and divided with the same value because both will get cancelled. So instead of cancelling these two, I cancel this. So that 4 by 100 is found to be 0.04 seconds. So what is given? Ratio of wavelength and frequency. But what type of wave it was given? It was given both are sound waves. When both are sound waves, they travel with the same speed. So V is constant here. So as we know that V is equals to F lambda. V is equals to F lambda. And two sound waves traveling in the air means they travel with the same speed, approximately 340 meter per second. So V is constant. Whenever V is constant, we get a relation between F and V as F is proportional to 1 by lambda. That means, simple form I can say that F lambda is constant. Whenever you obtain this type of relation, we can say that F1 lambda 1 is equals to F2 lambda 2, because always any number of values, the product always remains constant. 1 lambda 1, F2 lambda 2, F3 lambda 3, F4 lambda 4, all the values, the product always remains constant. So comparing these two, so what is given, children? Wavelength ratio was given. What is the wavelength ratio? Lambda 1 by lambda 2. Okay, so equals to, how much is that? F2. I brought this lambda 2 here and F1 the other side. This will be lambda 1 by lambda 2 is equals to F2 upon F. So moving ahead. What is the value of lambda 1 to the lambda 2 given? Wavelengths are in the ratio 1:3. So 1 by 3 is equals to F2 by F1. I just substituted the given values. Instead of lambda 1 by lambda 2, I substituted 1. But you are asking the ratio of the frequency. Ratio of the frequency means not F2 by F1. They are asking for F1 by F2. Then what is F1 by F2? If F2 by F1 is 1 by 3, then F1 by F2 must be equals to reciprocal of that. That is 3 by 1, or in the ratio format, it can be written as 3:1. Hence, the correct option is option number 3. Got it, children? So, well, moving to the next question, that is 23. The wavelength of a sound wave is 66 meters. Wavelength lambda is given as 66 meter. Calculate the frequency of the wave. The velocity of the sound is 330 meters. Velocity is given as how much? 330 meters, and lambda is given as 66. Okay, ask you to find out frequency. What is the relation between the wave velocity, frequency and wavelength? Of course, V equals to F lambda. Velocity, frequency, F must be equals to, bring the lambda other side, V by lambda. This is what you are asked to find out. Value of V, velocity of sound, V is given as 330 meter per second, and the value of wavelength, the wavelength of a sound wave is given as 66 meter. Both were given in SI system. So let us simplify this. This goes 6 times with 11, and this goes 3 times, so 30 times. Okay, 11 3s 33, 0, and 11 6 66. And again this will goes 5 times. Hence, the value of frequency is found to be F is equals to 5 Hz. What is the value of F, children? F is found to be 5 Hz, and here the third option must be true. So now the next one, 24. A sound of wavelength 68 centimeters. Wavelength is given as 68 centimeters travels 850 meters in 2.5 seconds. Okay, time taken is 2.5, distance traveled is 850. You're asked to find the velocity of sound as well as the frequency of sound. So children, first of all, let us recall back the definition of velocity. Velocity is defined, the wave velocity is defined as the distance traveled by the wave. Distance traveled by the wave to the time taken. This is what the definition we have given you. Okay, formula wise I told you that lambda by t. When is lambda by t? We have supposed that wavelength as lambda in a time period. See, then in that case is lambda by t. But general formula, general definition for wave velocity is distance traveled by the wave to the time taken. How much is the distance traveled by the wave given, children? Sound wave travels a distance of 850 meters in 2.5 seconds. So substituting all those values, 850 meters in 2.5 seconds, you can simplify this. 2.5 can be written as 850 upon 25 into 10 power minus 1. This 10 power minus 1 goes up 850 into 10. Decimal I removed and I kept it as 10 power minus 1. This 10 power minus 1 taken up indicates minus 1 will become plus 1, 10 upon 20. So let us now try to simplify the same. So this goes 5 times and here goes 7 5s 35 and here again 5 3s 15, 5 4s 20. So 34 into 10. Hence the velocity of the wave is found to be 34 into 10, that is 340 meter per second. So first one must be 340 meter per second. But let us also try to find out the second answer for this. Second one are also asked to find out the frequency. Children, well, what is the value of frequency? So as we know that F is equals to V is equals to F lambda or F is equals to V by lambda. Value of V, how much? Speed of sound is, just now we calculated it as 340 meter per second upon the value of wavelength. How much is the value of wavelength given, children? It is given as 68 centimeter. Centimeter, let us convert to meters as 68 into 10 power minus 2 meters. Okay, simplify, children. See, look at this carefully. I'll bring it up. 340 into 10 square comes up, means it will become 100, that is 10 square. 10 power minus 2 goes up, become 10 square upon denominator it is 68. Got it? So this 34 ones and 10, this is 34 twos. This will be 10 into 10 square, 100 into 10, that is 1000 upon 2, and hence the final answer here is 2 goes 500 times. Therefore, the final answer is found to be F is equals to 500 Hz. So, second option must be true. So, what is the correct answer? Children, moving to the next question. Question number 25. In the given figure, a displacement distance graph for a wave is shown. Okay, a wave is drawn taking a displacement on y-axis and distance on x-axis. Even the velocity of the wave is given as 320 meter per second. Wave velocity is also given. Some graph is given. You are asked to find the value of wavelength, frequency and amplitude. So let us try to find out one by one. The first case regarding the wavelength. So wavelength, only wave velocity is given and frequency is also not given. So let us look at the graph. So wavelength means the total length of the wave. So wherever at some position, mean position, it has to start going the up motion, again the same mean position, the other extreme position coming back. This total length of the wave from here to here itself is called as your wavelength, indicated with the letter lambda. This is your wavelength, indicated with the letter lambda. So what is this distance, children? The total distance from here to here, this itself is given in distances. No, from here to here, what is the distance? It is 0.4 meters. From here to here, 0.2 meters, 0.4 meters, 0.6 and so on. So what is the length from here to here? It is 0.4 meter. Directly from graph, we can say that wavelength lambda is 0.4 meters. Very clear from the graph. Okay, so now let us move to the next part of the question, that is B. What is asked in B, children? You are asked to find out the frequency. Just now we calculated the value of lambda and the velocity was given. So what is the relation between the wave velocity, frequency and wavelength? It is V equals to F lambda. So as you are asked to find out the value of F, bring the lambda to the other side. It will become V by lambda. What is V? 320. What is lambda? 0.4. So now simplify this. This can be written as F is equals to 320, as decimal removed means increase it upon 0, into 10 into 10. We have 3200 upon 4 is 8 4s 32. So answer is 800 hertz. So first one you found it as 0.4 meter. As a wavelength, frequency you found it, measured it as 800 hertz. And what is the amplitude? From the figure it is very clear that amplitude means maximum displacement of a wave from its mean position. So this length. So what is this length equals to, children? It is equals to 2 measured in centimeters. So answer is 2 centimeters. From graph again we found that amplitude A is equals to this pink color. How much is that? 2 units is centimeters. So here are the 3 options. First option 0.4, second option 800 and third option 2 centimeters. So third option must be true. I hope it's clear, children. You need to study the graph carefully. Now the 26th, calculate the wavelength of a sound wave whose frequency is 220 Hz. How much is the frequency? 220. Speed 440. That's it. Relation between the speed, frequency and wavelength. Let us recall back. Speed V, frequency F and wavelength lambda. That's it. V equals to F lambda. You're asked to find out lambda. So lambda can be given as, bringing the F other side, V by F. What is the value of V? 440 and frequency is 220. Simplify, it can cancel. 0 gets cancelled. 2 goes 2 times. 22 into 2 is 44. Hence the value of lambda is found to be 2. SI units it is measured in meters. Hence lambda equals to 2. So third option must be true. So now let us move to the last question of level 2. A person is sitting 200 meters away from a 20 Hz sound. So how far is the person? So this is a person who is at a 200 meters distance where a sound is being produced. Okay, what is the time interval at which successive compression pulses from the source reach him? So, ask you to find out the time period. Children, we know the time period is equals to 1 by frequency. The reciprocal of frequency itself is nothing but your time period. So, whatever be the distance, if you know the frequency, simply find it. So 1 by frequency, 1 by 20 is nothing but, so how much is that, children? It can be again 1 upon 20 is nothing but, for your easiness, what I do is I'll multiply and divide with 10. So again this 1 by 20 is there. So simplifying further, 0 gets cancelled. So what is the value? So 20. This is nothing but 10 upon 2 into 100. This goes 5 times. 5 upon 100 is 0.05. Time period is measured in seconds. So 0.05 seconds. I hope this is clear. Just simplify it by time, multiplying and dividing with 10. So the total it will be 200. 200 I wrote it as 2 into 100. 2 simply goes 5 times. So 5 upon 100 is nothing but 0.05 seconds. That's it, children. So let us conclude this exercise from here and let us meet in the next concept. So until then, take care.